Welcome to the deep dive. We are jumping straight into the source material today. We're looking at a phenomenon that has, well, baffled scientists and frankly terrified witnesses for centuries. Think of something caught right between a terrifying electrical storm and a complete unexplained mystery. We are plunging into the sources on ball lightning, that rare, luminous, and just utterly strange sphere of energy that seems to break all the rules. Our mission today is pretty clear. We want to get past the folklore and really analyze the witness descriptions, the real-world dangers, and most importantly, we're going to dissect the 5 leading scientific theories trying to explain this thing.
And this deep dive is so crucial because ball lightning, it isn't just some quirky weather event. It actively challenges our established understanding of electricity, of plasma. How does energy even hold a shape like that in the open air? It's been seen for hundreds of years, but it's still one of the biggest unsolved atmospheric puzzles. It really shows a huge gap in what we know.
Okay, let's unpack that. The core description first. When someone says they saw ball lightning, what are we actually talking about? Because it's not a normal lightning bolt.
No, not at all. We're talking about a physical glowing sphere. Witnesses pretty consistently describe it as glowing, sometimes white, sometimes red, often blue. And the size can vary, but usually it's somewhere between, say, a tennis ball and a football.
Okay. But the really baffling part is how it behaves, right?
Yeah.
And how long it sticks around.
Exactly. The duration. Conventional lightning is, what, milliseconds? A flash? This thing lingers.
Yeah.
For several seconds. I mean, some reports say up to a minute before it just disappears.
That lingering quality is what feels so unnatural. If it's just an electrical discharge, it should just ground itself instantly. But the sources describe this bizarre movement.
It doesn't strike. It floats. That's the key difference. It moves slowly, hovering, drifting almost horizontally. It seems to completely ignore wind or gravity. And when you look at 200 years of reports, it gets even stranger. Some people describe its movement as almost alive. Yeah, like it's searching for something or just meandering around.
But the detail that always gets me, the one that really pushes it into science fiction territory, is that it goes inside buildings.
Yes. The reports are consistent on this. It can pass right through a window frame, enter a room, travel along a wall, and it seems completely undisturbed by solid objects.
So hold on, if this is an electrical discharge, how can it go through glass or travel along an insulated wall? I mean, that just breaks like every basic rule of physics we have, right?
That is the ultimate paradox here. The energy is somehow contained and stable enough to navigate a room. It suggests the ball isn't acting like a normal electrical current looking for a ground. It's more of a self-contained structure, which brings us to the question of danger.
Right. And this is where it gets critical. Is this just a cool light show, or is ball lightning actually dangerous?
Oh, it's genuinely dangerous. While it's incredibly rare, the incidents we have on record confirm its destructive power. It's known to cause serious fires. It can melt metal.
Melt metal?
Yes, and leave scorched trails behind. The amount of energy packed into that little sphere is huge, and when it finally dissipates, it can sometimes be explosive. Witnesses have compared it to the force of a small bomb going off.
A slow-moving, exploding bomb that can fit through your window? That's staggering. And we have modern proof too, don't we? The sources mention that video from China.
The train track video, yes. That's vital. It shows his glowing sphere just traveling over the tracks, holding its shape perfectly before it just vanishes. That video takes it from historical anecdote to something we can see and verify today.
It confirms the weird movement, the stability.
Exactly. But it also leads to the central puzzle. If we have video and centuries of consistent accounts from, soldiers in WWII to modern witnesses, why can't we study it?
So what does it all mean? How can something so clearly real still have no definitive scientific explanation?
Well, that's the big question. We know it exists, but we can't catch it. It's the ultimate elusive target. And it's for 2 reasons. It's incredibly rare, and it's incredibly fast.
It appears without warning.
With no warning at all. And then it's gone in a few seconds. That's just not enough time for anyone to capture it or analyze what it's made of in a lab. It just resists every attempt to study it.
It's like trying to photograph a specific lightning bolt with an old manual camera. You know it happened, but you didn't get the shot.
That's a perfect analogy.
Yeah.
Exactly. So because we can't analyze it directly, scientists have to rely on hypotheses. They've basically developed a framework of 5 main theories, all trying to explain how this thing forms and, crucially, how it holds itself together.
Okay, so this is the core of our deep dive. Let's get into these 5 attempts to explain this. This ghost of electricity. It seems like we have competing ideas here. Some say it's energy, some say it's vaporized earth.
Right. Let's start with the classic electrical one, the trapped plasma hypothesis.
Yeah.
This theory suggests the ball is a sphere of plasma that's superheated ionized gas, the fourth state of matter.
Okay, plasma. That makes sense for lightning, but what's the problem with that theory?
The problem is stabilization. Plasma is incredibly unstable. I mean, think about fusion research. We spend billions building massive magnetic containers just to hold plasma for a fraction of a second. For this ball to just hold itself together in the open air for several seconds, that's a monumental physics challenge.
So it's not if it's plasma, it's how the plasma doesn't just fly apart instantly.
Precisely. Now, theory number 2 moves away from pure energy and into matter. It's the vaporization of Earth materials idea. This one proposes that when a really powerful normal lightning bolt hits the ground, the intense heat vaporizes minerals in the soil. And the main candidate here is often cited as silicon.
Silicon, you mean like sand?
Exactly.
Yeah.
The source material suggests that this vaporized silicon gets charged, collects into a ball, and then it floats and burns slowly. And what's really interesting here is that the slow, contained burning of these silicon nanoparticles is one of the leading explanations for the ball's long duration. It suggests the ball is more of a slow chemical reaction, not just a fleeting electrical event.
So that turns it into a little temporary chemistry experiment just hanging in the air.
Okay, theory 3 takes us back to pure energy, right?
Yes, the trapped electromagnetic waves theory. This one's pretty abstract. It suggests the ball isn't made of matter at all, but is a self-sustaining electromagnetic resonance. Imagine energy waves trapped inside a kind of spherical bubble of air. This could explain why it can pass through glass without shorting out. It's not really touching anything. It's a field creating its own container.
Right, so that theory explains the weird movement and going through walls, while the silicon one explains how long it lasts. They're solving different parts of the puzzle, which is why they all compete.
That's right. Now let's look at the fourth theory, which is combustion of nanoparticles. This is pretty close to the silicon theory, but it focuses on the microscale. Instead of a big ball of gas, this idea posits that it's just microscopic particles, nanoparticles that are released from the ground strike.
And these are particles so tiny they just float on air currents like dust. Exactly. They're so light they can just hang in the air. These little silicon or carbon particles are highly reactive, and they just slowly oxidize or burn over those crucial few seconds. And that provides the light and the duration. This theory has actually gained a lot of traction because physically it works. A cloud of burning nanodust could last that long.
Okay, that leaves one more, the fifth one, which brings the environment into it, water.
Yes, the fifth theory is an electrical reaction with water vapor. This suggests that ball lightning is the result of a very precise, very rare set of conditions. You need intense heat, you need extremely high humidity, and you need the electrical charge all at once. And the interaction between the charge and all that dense water vapor somehow creates a unique temporary structure that holds itself together.
Wow. So we have 5 incredibly detailed, scientifically rigorous attempts to explain this terrifying sphere that lasts, what, a few heartbeats? The tension is still there, though. Is it a structural problem, a material problem, or a plasma problem?
And that's the core mystery. It's a powerful reminder that even in our own atmosphere, there are things happening that resist our neat categories. Ball lightning is a known natural event, but its behavior, it just looks like it belongs to another world.
So connecting this to the bigger picture, this thing which shows up so rarely and resists all analysis, it just reminds us that nature is, well, it's far more complex than our current models.
We've established that this is a confirmed phenomenon that just operates outside our predictable rules, which is why scientists are so obsessed with cracking the code.
So here's the final thought for you to consider. We're making huge advances in technology, right? Especially in things like plasma containment for fusion energy, a field built around stabilizing plasma. So will the ability to finally replicate this unplanned event in a lab unlock some fundamental secret about sustainable energy? What will it take to finally catch a secret that lasts only for a few seconds?